Hello everybody, the late afternoon survivors. My name is Paul Poliwoda, and the $1 million question, or actually a $10 billion question that we're trying to answer today is how do you build an application in 1 month, right? So 10 billion is a relatively random number, but it's also a personal net worth of one of the founders and one of the developers of WhatsApp, right? And as you know, WhatsApp was sold to Facebook, and the developers made lots of money out of it. But before we go deeper into that, let me quickly introduce myself. My name is Paul Poliwoda. I'm a lead consultant for EMEA in DevOps technologies. So I'm in IT for, since I actually remember, officially paid for it for the last 15 years. I started throughout pretty much throughout all of the steps in the technical fields of IT, right? Starting as a technical support engineer, replacing probably 10 tape drives a day, and for those of you who remember those terrible devices. Then I made my way through to the software escalations, and then into an L4 fly and fix, they call us Skybench, right? So in the meantime, I also made my master's degree in artificial intelligence. Apparently the concept of free time and social life is something I hated. The fact that I studied it actually made me love the concept of the patterns. Right? So whenever I was fixing things and having occasional naps in the data center floor, right, for those of you who know how it works, it's called the maintenance window. Right? I was also studying how these technologies that I'm fixing are applying to the business. Right? How do they influence the business? How do they benefit the business? Right? That's how I moved into consulting. Right? So, for those of you who may say, okay, Dell laptop guy, what did you do in the data center, right? You guys do laptops, right? So a quick note, because it's confusing even internally, right? There is the Dell laptops business, and then there is the Dell Technologies business, and then there is the Dell EMC business. The way it works, the way we are structured, is that there is the Dell Technologies, which is the umbrella company, the holding of other companies, and we are a family of 7 companies, where we are actually leaders in majority of the fields that we embark. Dell EMC is a leader in the data center equipment. VMware, as you know, is a leader in virtualization. Dell leaders in laptops. We also have RSA Securers that are leading the way in security, and Virtustream in managed services. Right. So enough of product placements. Let's get back to our initial question. So, how many of you is actually directly involved in software development lifecycle, in SDLC? Right. So we have a good mix. How many of you can tell me what these companies have in common? Okay. Yeah. They are related to the cloud. That's correct. Are they IT companies? No, they're not, right? So, Tesla is a car company, right, automotive company. Uber is a transportation company. Netflix is a streaming or a video company, right? However, all of them, they're using IT and technology to get an edge, right? Also, all of them, they are disruptors of the industry, right? Now, what those companies have in common? Anybody? So these companies are the opposite of the first ones, right? They used to be the leaders in the industry. However, they did not change fast enough. They were not agile enough, and now they're not there anymore. Right? There's other companies that took their place, right? So there's a story about Carl Darwin going to the Galapagos Islands, right? So when Darwin went over there, you know, Galapagos is a set of islands, a lot of them actually. He found the finches. So finches are those little birds, right? What he found interesting about them is that in every other island, depending on what food was available, the same bird was having a different beak, right? So in the islands where the fruits were in abundance, the finches they were having strong and big beaks, right? While in the places where the birds were chasing the insects, they had to put the beak into the smaller tight places, right? The beaks were longer, but very thin, right? So this finding allowed Darwin to form the theory of the natural selection, right? Which means that if you want to paraphrase it into very simple terms, if you don't change, if you don't adapt to the environment, you will die, right? Your species is going to extinct, right? Now, looking at the previous slide, like Kodak or BlackBerry, they were the guys that were very resistant to the change, right? They didn't want to adapt. Right, and we can see what happened. Right? So, what else is important when it comes to the successful business? Right. So, there's a gentleman called Bill Gross. Right. And Bill Gross is an investor. Right. He manages a portfolio of over $200 billion. Right. So he probably knows a thing or two about a new business. Right. So what he says is that the timing is extremely important, right? It's probably one of the most important things when it comes to forming a successful business, right? But we're here, right? We're here in the Agile forum, right? Agile community. We know that Agile is all about changing fast. It's adapting to the business. It's adapting to the changes in the industry, right? As the gentleman in the very beginning mentioned in his presentation, Google is giving away the know-hows, because they know by the time that we are already here, the market is going to change, right? So if you want to adopt agile technologies and agile methodologies, you need to change faster and you need to fail more often. Right? Now, it all sounds good, right? But why not all of the companies are applying this, right? Because there's plenty of businesses that are still following the same models, right? Their IT is slow, everybody's complaining that it doesn't work as fast as the business, right? Well, that's why. Right? So this is a diagram of a simple IT process, right? It's actually an ITIL, which is a standard in the IT industry that defines the processes in the IT department. If you look at it, there is a lot of silos of the teams. There is a lot of approvals. There is a lot of processes that are overlapping. Things are just slow. The IT is being organized around the processes, not around the pure value of what they're supposed to do. Right? So who can tell me what is the primary role of an IT in the organization? Primary role of the, sorry, please?
Support business.
Perfect. That's correct. So the IT is there to provide the support for the business, to enable the business, right? And for those of you that your IT departments are telling you differently, right? My colleagues from IT as well are telling you differently. Tell them that they're wrong, right? They're there to support you and to support your business, right? Now, what do they provide? They provide service, right? And in a well-structured organization, the services are cataloged, right? So we say that a well-structured organization have a so-called service catalog, right? These services, they can be the traditional one, right? So we're talking about email, file sharing, probably some customer relationship management, the traditional services that an IT would provide. However, the companies are also embarking on the digital transformation, so they start to provide the services outside, right? So their customers are not just the internal departments, however, they're also providing the services to the external customers, right? So those services would be the mobile applications, there would be the web applications, hybrid, the solutions in the right? So let's go a little deeper, right? So in order to answer, how do we improve it? How do we improve the operations inside of IT department? How do we become agile, right? Because this is really the purpose of our workshops over here. How do we really apply agile in a structure that is not very agile, right? In a structure that is pretty slow by definition, right? In order to answer that, we need to answer what is really a service, right? So let's go one level below, right? I promise I'm not going to kill with IT, right? This is an architecture of a simple service, right? Let's call it a web application, right? The web application consists of a few components, right? So again, without going too much into the details, you have a load balancer, which is a system that provides you redundancy between two servers. This is one server, application 1, and application 2. Right? Your load balancer provides you high availability between these two components. And then you have two database servers for the same reason. Right? If one of the database servers fails, the other one takes the place. Right? Now, I promise this is the deepest zoom that we're going to go, right? Let's break down every application. What really is an application, right? So we have a service, and we have multiple applications that are forming the service, right? We're still talking about this web application. Every single application really consists of a few repeatable blocks, right? So if we look at it, every application can be transformed into something that you can see in your personal computer, right? So you will have your CPU, your processors, you have your memory, you have your disk, you have probably some networking things, right? On top of it, there is an operating system, right? So that's going to be your Windows 10, your Linux, or any other application, right? And then it starts to get interesting because there's the platform, right? So platform is really what provides you the mechanics. So platform is, let's say, a database application, Microsoft SQL Server, MySQL, Postgres, whatever you're going to choose, right? It also can be a web server, right? Apache, IIS, or whatever, right? But this platform is what provides you the functionality around the specific domain. And then on top of it, you have the code. Code is what really enables the platform to do what you want, right? So code is going to provide you the so-called function of a specific application. So that was the deepest as we're going to go. Actually, as a matter of fact, this service architecture probably is not complete, of course. It's more conceptual. But you can say that majority of even the most complex applications in the internet, in the mobile world, in the digital world, are being based and are being built using similar components, right? So we understood how a service is built. Now, what if we want to build our own, right? So we're starting the journey of building our own website. Right? So let's look at the process of how the traditional software lifecycle looked like, right? And bear with me, we're going to get to why we're going into this, right? So the traditional software lifecycle looks the way that there is a company. Usually, it's not a software shop, right? It's a retail, brick and mortar, right? Can be development. Sorry, can be a construction, right? It's actually a real example from one of companies I know that's in the construction business, right? So they decided they want to embark on a digital transformation. They want to provide extra value to their customers, right? So their core business was not IT. They just wanted to provide a mobile app to their customers in order to extend their services and be more attractive in the market, right? So what they did, they hired a bunch of developers, right? Very smart guys, really good guys, right? They understood their C#, their Java, right? They knew all of the web stuff, right? Very clever guys, right? They purchased some extra servers, right? They put them in the primary system, right? The primary production environment, and then whatever was scavenged out of it was left for the test and development systems. So what happened? The developers started to write the code, right? And they said, okay, good, we're ready, right? Let's push the code, let's test the code, right? As we mentioned, there is the item library over there, which requires a lot of approvals. There is a change management systems in place, right? You cannot just change stuff in the running system, apply code wherever you want without specific approvals, right? So these approvals, they took 2 weeks, right? And what happened is when they pushed the code to the servers, boom, doesn't work. Right? So since they were very smart, they said, okay, it works on our laptops. Let's change something and let's try again, right? So they pushed it again and boom again, right? So now they said, okay, there's something wrong, right? It works here, it doesn't work here, right? We need to change something. But since they're very smart guys, right, they said, you know what, let us fix it, right? We're not going to play this game of developing the systems in our laptops, pushing into the servers. We're clever enough, and by a combination of patching and sorcery, black magic, right, they made it work. And the application was working on the testing servers, on the development servers, right? So they said, okay, great, perfect, right? So it works over here. Let's push the application to the clients. Let's push it to the production servers, and let's see how it goes, right? So another change control, right? Change management cycle, right? Another cab. 3 weeks later, because usually those are the cycles over there, right? 1 a.m. Friday, right? Changing the management, the maintenance window as usual, right? They push the code and boom. And they crush the production servers. Right? So this cycle went for actually a few more iterations. I'm going to say that. But finally, they understood there's a problem that the software development lifecycle is not only about the technology, right? Having a smart developers is one thing. It's very important, of course, but it's not the end game. You have to have processes in place, and these people have to be trained. Now, what were the issues in the environment? There was multiple issues. The most common one that we see in the SDLs, right? So the code was being scattered all over the place. The laptops were having different systems than the development server. The development servers were having different systems than the production servers. The ops team have never spoken to the development, right? So the operations team speaks about networking, firewalls, security, updates. The developers are talking about the objects, MVC, variables, right? The common development stuff. When you ask the development team what is happening in the operations or what is happening with the servers, they say, well, we don't care, right? As we say in Poland, not my circus, not my monkeys, right? When you ask the ops team, right, what's happening in the development, right, what is happening in the code, same story, right? They don't care. So these issues are adding up, right? So they were not really able to push a successful code, right? They were not able to build their first app. So how does the good do it? So we saw all of the issues that can happen. Let's look at the process that actually works. It's a baseline of a DevOps system, right? By no means this is not complete. It's just a baseline to start to design a process. So we need to introduce the concept of a container. And you probably heard about the Dockers and the Kubernetes a lot of time, right? Let's quickly look at what really a container is. A container is a unit that looks exactly the same and works exactly the same on your development workstation, in a dev server, and in a production server. It will consist of exactly the same configuration of your platform, your code, and all of the dependencies around it. So that's the first new thing that they introduced. The other thing they introduced is a code repository. Code repository is a system where you push your code and it tracks what has been changed. You can actually put a name to a change and track the fact that you added a specific feature, right? So you don't have to think of what has been changed along the way, right? And then there is a new entity. It's called a continuous integration server. Right? So bear with me. We're gonna go through what do they actually do? How does the workflow look like right now? So a developer or a team is building application. They're building their WhatsApp. Right? The system consists of a code for the actual application. There is a code for the platform that defines the platform, and there is also a code that defines the tests of the system. Right? The idea is that we have a full definition of how the end state is going to look like between the code of the application platform and the test. Now, these codes are being pushed into the code repository, right? So instead of putting it on the servers, you upload it to the code repository server. When the code repository server receives the code, it sends a message to the continuous delivery and the continuous integration server that gets the code from the code repository, puts them on the dev servers, and executes the tests. Right? The idea is that all of the testing that normally would be done by the manual team, by the team manually, is being executed by a script and by a set of technologies. Now, what happens next? Nobody's perfect. Developers neither, right? They made mistakes. Doesn't work, right? It didn't work in the development server. Now, what's the difference between this workflow and the previous workflow? Now, this whole process didn't require any approvals. It has been standardized, and it took 6 hours, right? Because they wrote a bunch of code, right? They pushed it. It went to the dev servers. The test failed. No tragedy. Nothing really happened. But it's done, right? Within 6 hours, they knew that things are not working. Right? Now, since they had a code repository, they could see what has been the last change that they did, and they could revert it. Right? Now, since they knew what happened, they fixed it and they pushed the code again. Again, continuous integration, continuous delivery server run the code. They put it in the container on the dev servers. Now it works. Right? Again, that was done the next day. It was instead of 3 weeks, or actually 5 weeks in the previous scenario. That was 2 days because the whole process has been altered. Now, in every pipeline, you know, there is always the code review. There is always a human interaction, right? We don't want things to be fully automated, just for the bad things not to happen, right? So there is always the last review, right? We call it code review or final approval, whatever it is. It's called in a specific company, right? So this is a process where there is a team of developers that is looking into the state of the system in the dev servers and is giving the final tick box. Once the final tick box is done, the code is finally moved into the production server. Now, the third case that all of those servers are the same, they're protected in the same way, so there's no surprises. There's 99% whenever it works on the dev servers, it is going to work in the production server. So that was intense, I imagine. Right? That was quite in depth when it comes to the infrastructure. But now let's take a different scenario. Right? You have a developer, right? And you don't want to go through the whole hassle, right, of setting up the DevOps process. You don't want to purchase your servers. You don't want to deal with all of this stuff, right? You have a good few developers who just want to deploy the code. We want to write something and deploy it somewhere. In order to do that, we need to talk about the concept of a cloud. Right? So what really is a cloud? Right? In order to understand what is a cloud, the best way to tackle it is to really understand what kind of services or what kind of benefits the cloud provide to a business user. Right? So remember when we were breaking down the application, again, your laptop, right? We can break it down into individual components. Right? So you are going to have your machine, right? So it's going to be your hardware, keyboard, motherboard. You're going to have your CPU, right? Your processor, your memory, your disk. And you're going to have the operating system. Right? So when it comes to the cloud, this set of services is called an infrastructure, or how cloud calls it, an infrastructure as a service. So what it really means is that if you're purchasing cloud services, you can say that, okay, dear Google, Amazon, or Microsoft Azure, I would like to have a machine deployed somewhere in the internet that has 2 processors, that has 16 gigs of RAM, that has Windows 2016 installed, and that's it. I don't want anything else from you. I'm going to install everything on my own, right? This is called an infrastructure as a service, right? The most common feature of any cloud. But why are we talking about it? The reason why we brought up cloud is because we want to simplify things. We have the developers, and we don't want to play with building Apache. We don't want to play with building databases, right? We just want to push the code and make it work somewhere. So this offering is called Platform as a Service. Platform as a Service is a combination of all of this, right? So your basic compute unit, but you also purchase a license and pretty much management of the platform. So in here, if we purchase Platform as a Service, we are saying that, okay, dear Microsoft or dear Amazon, I would like to have just a blazing fast database. Right? I don't care where is it running, what kind of specs is running, it just has to be fast. Right? We want our database and we want a bunch of web servers, right? And you manage it for us. Right? This is called Platform as a Service, right? a very specific type of a platform as a service. It's called a container as a service. Right? So remember in the previous slide we could push the specific containers. Right? You can purchase the system for the containerization also as a service. Right? And finally, there is the top level of the cloud, which is starting to be more and more popular. Still yet not adopted that fast. It's called function as a service. Right? It's another service of the cloud providers. So what function as a service is you say, okay, dear Google, I would like to purchase artificial intelligence as a service, right? So I would like to have a 100 images recognition. I'm going to send you 100 images, and you recognize the faces, right? So this is called a function as a service, and you can also purchase it as pay as you go. So what cloud really is? When it comes to technology, it's the most common meme on the internet, right? On the cloud. There's no cloud. There's just somebody else's computer. It means that Microsoft, Google, Amazon, they have really big data centers, right? And they know how to make the data center business, right? So they build the servers, they build the platforms. They probably do it better than most of us, right? Now, based on the huge system they have. They put it into chunks and they give it to you as a service, meaning that you can pay as you go, meaning that you can spin off a huge infrastructure that will cost you a good few millions to put it in your data center. You can spin it off for 3 days just to test the project, right? You can deploy your code on it, right? You can test it, and you can shut it down, and the bill is still going to be probably in thousands, not in millions, right? The other thing is that everything is standardized. So when you're deploying something to the cloud, it is going to work, right? I mean, if it's going to work on one part of the cloud, it will work anywhere else, right? And finally, there's a scalability, right? So again, let's say today we're deploying a shop, right? An e-commerce solution, and it works, right? We have 100 customers per day. We're very happy with that. Suddenly, we have a brilliant marketing guy that is bringing in 2,000 customers per day or 5,000 customers. Right? The same servers that were deployed before to handle the load, now they're going to be killed. Right? So what would you do in a normal situation? You would probably go through the procurement process, you would purchase new hardware, it will take you probably a good few months, and you will lose a lot of customers and obviously a lot of money. When you're running cloud, you can apply dynamic scalability, right? So the same systems that are working in a smaller scale, you just put a bit more money on it, they're going to grow in a standardized way. So you may say, okay, but we live in Middle East, right? So Middle East has a lot of laws around data sovereignty, right? We cannot really move the data around. We cannot move the data of the customers from the country. We cannot go to Europe or China. So we cannot use cloud. Now, cloud classically is being referred to as a public cloud, right? So when we normally define a public cloud, people just simplify it and call it a cloud, right? So those are the classic providers of Google, Azure, and AWS, right? However, there's also the private providers of cloud, right? So we have, for example, solutions like VMware vRealize, we have Red Hat OpenStack, we have Pivotal Cloud Foundry. All of these solutions are providing you some of the benefits, not all of the benefits of the public cloud, because the dynamic scalability, of course, is going to be a bit of a challenge. But the standardization and the self-service are there, right? And a number of other benefits. So if you cannot really move into the public cloud, you can still deploy it on premises using these solutions. Now let's combine these two and let's build a solution. Right? So I promised we're going to build a WhatsApp, right? In 1 month. How do we do it? Right? So it's a framework. Don't kill me for it, right? I want to make $1 billion or a $10 billion business. I'm going to build an app for you, right? Or you're going to build it for the sake of the art. How can you do it? The fastest, the most agile way out there. What you can do is you can hire a bunch of people, hire a team. Right? This can look scary, right? But you can imagine that these people, they're available on the market on all of those freelance sites. You can hire them on the basis of the month, week, or even per hour. Right? So you need a specific team structure to build your software. Right? You probably need an architect. You probably need a DevOps guy that is going to design the automation. You need one or two good developers, right? Then you get the automation, right? So you get your code repository and the continuous integration server. So remember, this is keeping your code. The continuous integration is doing the deployment. Right? Then you purchase the platforms, right? Now, the trick is that each of these can be purchased almost down to an hour, right? So you can pay per hour of utilization of each of these resources. So let's say we have a brilliant idea. We want to develop an app. We could potentially use this framework with a bit of improvement, of course, and build something, an MVP, that is going to be up and running. And I can guarantee you can do it below 1. So to close, to share a quick story, a small story that I've heard about there's those hanging monasteries in Greece, right? And there's a story about one of the tourists that went for a tour over there. And in order to get from one hill to another, you have to go in the rope basket. So the tourist got into the basket, the monk was about to take off, right? And the tourist just spotted that one of the lines is damaged, right? It's stripped, right? So he asked the monk, what's going on, right? How often do you replace those ropes, right? The monk said, well, they're broken. So those ropes, they were the solutions to this guy's business, right? Because this monk business was willing to take the people from one hill to another. But those ropes can be think of also as solutions to our businesses, right? There's lots of companies that their processes, they start to be damaged, they start to be stripped, right? But they just let it go, right? For complacency, for laziness, for a number of reasons, but they allow the processes to fail, and only then they start to replace, right? We are living in a very competitive times. We need to make sure that we look at our ropes and the processes in our business. Very often we need to be agile and we need to replace them with their